Welcome back, everyone. This is the second part of our factoring review. I'm Mr. A here, leading the charge into the second part of factoring number 2, as I'm calling it. All right, well, let's get right to it and see what we're going to do today. Our objectives for today: we want to be able to factor a polynomial using difference of squares. Usually people like this one a lot. Number 2, factor a perfect square trinomial. 3, solve a quadratic equation. Like we've been doing before, it's going to be the same pattern. And then number 4, write a quadratic equation in standard form given the roots or given the solutions or the answers. Okay? All right, first of all, difference of squares. Difference of squares, it says right in the name here what this is. Okay, first of all, what's difference mean? Difference is subtraction, remember that? So, first of all, in order to be difference of squares, it has to be subtraction. It has to be two terms, and both terms have to be perfect squares. So that's what you're looking for difference of squares. All right, first of all, is x squared, is that a perfect square? Can you take something times itself to give you x squared? Yes, okay. That would be x times x, and I'm going to write it this way, and you'll see why in a second. What about 81? Can I multiply something by itself to give me 81? Yes. 9 times 9, or 9 squared. So there are two terms. They're both perfect squares, and it's being subtracted. So this is the difference of squares. So once I've determined that, and I see what it is that's getting squared on each one of these, the pattern is basically just a pattern to memorize. It says since you have two x's here getting multiplied together, one goes here, one goes there. Since you have two 9s multiplying together, one goes here, one goes there. And it's always going to be plus, minus. That's it. X plus 9, x minus 9. So every time that you determine it's a difference of squares, it's always going to be one's plus and one's minus. Okay, all the time. Because you notice, remember how we talked about before, if you FOILed a couple of parentheses together, you would get what you started with? Well, in this case, when we do it, x times x is x squared. But what happens, and then 9 times negative 9 is the negative 81, but what happens in the middle? The OI in FOIL, you're going to get a negative 9x and a positive 9x. What happens? It cancels. So in order to get one that has not two terms, but three terms, or I mean not three terms, but two terms, it has to cancel. So one of these has to be plus and one has to be minus. So that's how it will cancel. Okay? All right, let's look at the next one. A little trickier, but let's see what we can figure out. Are there two terms? Check. All right, is this one a perfect square? Well, it's going to be 2h times 2h, or 2h squared. And then what about 25g squared? 5g times 5g, or 5g squared. So two terms, they're both perfect squares. Is it subtraction? Yes. And so the pattern here tells me 2h plus 5g, 2h minus 5g. That's it. So no matter how complicated these are in here, if you can figure out that it is a perfect square, you just follow that pattern, plus minus. Now, one thing, and I don't think I mentioned it on one of these slides here, but remember, if you had something like x squared plus 25, and you said, oh, that's x times x, and 5 times 5, but you know what? This is plus, not minus. So you cannot factor this. This is not the difference of squares. You cannot factor it this way. You would have to call this one prime. You cannot factor it. A lot of times people think, oh, I could just make it instead of you know, plus minus, I could make it x plus 5 and x plus 5. Well, that'll give you 25, but you know what happens when you get rid of the plus minus? That middle term doesn't cancel out anymore, and then you'll have a middle term. And actually, that's what, in the other type of factoring we're going to talk about, perfect square trinomial, that's what happens there. So if you see a plus here and there are two terms, it is prime. It is, you cannot factor it. All right, let's look at a couple of equations where we have to solve. All right, same steps that we want to take just as we did before. So first of all, does it equal 0? Yes. Is it factored? No. All right, so let's factor it. There are two terms. Is m squared, is that a perfect square? M times m. What about 16? 4 times 4. So the pattern here tells me m plus 4, m minus 4. So we've got it factored down into the two parentheses. Now we just have to figure out what does it take to make each parentheses equal 0. Well, in this case, m would have to be negative 4, because negative 4 plus 4 is 0. And this one would give me positive 4, because 4 minus 4 is 0. So 4 and negative 4. Sometimes people like to write it this way, and you might see this plus or minus 4. You might see that notation. That would be totally fine if you want to do that to save yourself some time there. That just means both the positive 4 and the negative 4 is what that means. All right. Second example, is it equal to 0? No. Okay, so we have to make it equal to 0. So I'm going to go minus 9, minus 9. So that gives me 16a squared minus 9 equals 0. All right. Let's look and see, we have two terms, so we're going to do difference of squares, obviously. Is 16a squared a perfect square? 4a times 4a. And 9 would be 3 times 3. So what's our pattern here? 4a plus 3, 4a minus 3. Hey, remember back in the last video, the little shortcut with these kind here? Remember, it's the number by itself, change that sign, and divide by the other number. So this is a plus 3, so it's going to be a negative 3 over 4. And this one is a minus 3, so it's going to be a positive 3 over 4. So there's our solution there, negative 3/4 and positive 3/4. All right, that's the difference of squares. Next, we're going to take a look at perfect square trinomials. Okay. Now, here's the thing let me say about this. There's another pattern to look for here. However, it's basically a shortcut. If you don't see that it's a perfect square trinomial, or this confuses you a little bit, you can still factor these trinomials the same exact way we talked about in the last video. You can do that same pattern will work. It might, you know, like for example, this first one here is pretty simple, but the second one, you could do this and figure this out and do the box method and go through all the steps. Totally fine. You should be able to get the same correct answer. But what I'll show you is a simpler way to do that if it's a perfect square trinomial. So totally fine to do these the old way that we talked about last time. This is basically a shortcut. Okay. All right. So here's how this shortcut goes. If there are three terms, and you notice again it says perfect square trinomial. So trinomial means it has to be three terms. Perfect square, again, just like difference of squares, you have to have the first and the last term have to be perfect squares. So this one's going to be y times y. This is going to be 5 times 5. So here's what I would suggest is just kind of keep this in mind. Anytime you notice, you know, like a y squared and 25 or something like that, where you go, hey, those are perfect squares, there's one last thing you got to check to make sure the middle term is okay. Take a second to check that out before you go on to the rest of it. It might make it easier. Here's the last thing that you want to check here is this middle term. If the middle term is correct, it will be this number here, the 5, times the y times 2. So it's always this thing that was squared times that thing plus, or times 2. It's always doubled, or times 2. So basically, if you take the 5 times the y times 2, that gives you 10y. If that, or the negative of that, is this one here, and it is, this is a perfect square trinomial, and so what happens is this is going to be y and y, and then whatever sign this is a plus sign in here, so it's going to be plus 5, plus 5. Remember on difference of squares it was always plus minus. Here it's plus plus, or it could be minus minus. If that middle term is subtraction, it's a negative in the middle there, then this would be 2 minuses, 2 subtraction signs there. You could also write this like this. You could also write this as y plus 5 squared if you wanted to. That would be another way you could write that factored down. We could have also solved this the old way, totally fine. All right, so let's take a look at the second one here. 16n squared, you go, well, that would be 4n times 4n, and 9 would be 3 times 3. The old method, this you'd have to go, what, like 16 times 9 and get a big number and figure all that out. Could take a little while. But here you notice 4n squared and 3 squared. 3 times 4n is 12n, and then if we go times 2, what do we get? 24n. In this case, it's a negative 24n. Fine. You know, we're not worried about the sign. We'll deal with that in a second. So what this means here is that my factored down version will be 4n minus 3, 4n minus 3. Or you could say 4n minus 3 squared. And the reason why it's subtraction there is because of this negative sign right there. All right? So, again, just a shortcut, but if you see it, it might save you some time. If not, it will still work the other way. Let's solve a couple of equations now. First of all, is this top one equal to 0? Yes. Let's see, is this a perfect square trinomial? This is going to be 9 times 9, x times x. Is the middle term okay? Remember, what do we do? 9 times x, 9x, then double it or go times 2. If I go times 2, what do I get? 18x. Does that match? Yes, it does. So the pattern here tells me that it's going to be x. Here's a minus sign, so minus 9, x minus 9. And on this one, since both of these are the same thing, both parts are going to give me the same answer. So I'm going to say that x will equal 9, and that is actually the only solution that I get there. Just one solution. Okay, then this one, is it equal to 0? Nope. So minus 12g, minus 12g. Be very careful here too. Make sure you put these in the right order. Don't just do 9g squared plus 4 minus 12g. The 12g is going to go in the middle here. So you have to write this as 9g squared minus 12g plus 4. Make sure you get that in descending order. And then you say, okay, let's see here. 3g times 3g. 2 times 2, those are both perfect squares, so multiply them together. That's 6g times 2. Does that give me 12? Yep. So what do we got here? This is going to give me 3g, and then that's minus 2, 3g minus 2. Again, both of these parentheses are going to give me the same answer, so really I just have one answer here. Remember the shortcut? G would equal Remember, since it's minus 2, you make it positive 2 divided by 3. So our one solution there is that g is 2/3. Okay? So that's solving an equation with a perfect square trinomial. All right, one more thing. Here we want to take a look at writing a quadratic equation. We'll write it in standard form with the given roots. Okay, so these numbers that are given to you are the answers. Okay, so these are the answers, and we want to take the answers and write it back to the original equation. Okay, so remember what happened before when what we've been doing is doing this the other way, and now we're going to kind of go backwards. We always get down to where we'd have like two parentheses. You know, we'd have a parentheses times a parentheses equals 0, and then we'd figure out what it takes to make each part equal 0. And if you remember, like if this was, let's say this was x minus 2 times x plus 5 or something like that, what did we do? This part would be x would equal 2, and this part x would equal negative 5. So what happened? This is what we're starting with now, like the 2 and the negative 5, but here we're going to say negative 8 and 5. What we want to do is take this and write it back into the parentheses form, where if the answer was 2, when we put it back into the parentheses, it became x minus 2. If it was a negative 5, we put it into the parentheses, it was x plus 5. So with these two over here, if these are the solutions or the roots, when I put them back into parentheses form, it's going to be what? X plus 8 times x minus 5 equals 0. That's where those roots came from. And then in order to put this back into standard form, what do we do with two binomials that are being multiplied together? FOIL, FOIL. So let's multiply them together. X times x, x squared. X times negative 5, negative 5x. 8 times x, 8x. And 5 times negative 5 times 8 is negative 40. And combine the like terms here, so we have x squared plus 3x minus 40 equals 0. That's the equation that those roots come from. X squared plus 3x minus 40 equals 0. So we're just kind of doing backwards what we've been doing forwards before. All right, this last one, a little bit tricky here because of the fraction. But let's see what we can do. Remember, let's follow the same pattern. So that means this has got to come from what? X plus 1/3 and x minus 6 equals 0. Okay, so let's FOIL it together. So you got x times x, x squared. Then you're going to do x times negative 6, so negative 6x. Plus 1/3 x, and then 1/3 times negative 6 is going to be what? Minus 2, it looks like there. And so, well, how do we combine? We got like terms that we got to combine here. How would we combine those? We could just multiply. Let's see. Let's go ahead and make that an improper fraction. I think would probably be the best thing there. So this is going to be x squared. We got to go times 3. So minus 18/3 x plus 1/3 x minus 2. So that's going to be x squared, looks like minus 17/3 x minus 2. Now, that's not standard form because why? It's got a fraction. So what could we do to get rid of that fraction? If it's a 3 on the bottom, multiply this whole thing times 3. So when we distribute that 3, we get 3x squared minus 17x minus 6 equals 0, because 3 times 0 is still 0. So that's what we would end up with there as our quadratic equation. Now one thing, and hopefully this will actually work out here, that means I didn't make a mistake. One thing that you might want to remember that little shortcut that I was telling you about when we'd have it in a parentheses here, and it was like 3x plus 4, and we would do the opposite of 4 over 3 and things like that. We could kind of apply what we know from there to this. And that might help us instead of having to write x plus 1/3 and going through all this with the fractions. Remember, whenever we got an answer like this, this came from the parentheses where you divided by 3, so that meant that there was a 3 in front of the x. And then since it was a -1, that means it came from a +1. So if you can kind of remember that and work backwards, and then the 6 is still going to be x minus 6 like it was, this also should work. Because, you know, we did x plus 1/3 and then had to kind of deal with that fraction. But if you remember how this worked, remember when we had this kind of a parentheses, we'd do -1 over 3, and you can kind of work that backwards in your head. Now let's FOIL this together, and the rest of this is going to be a lot easier here, I think. So 3x times x, 3x squared, that's going to be -18x plus 1x minus 6. And now when you combine these, what do you get? -17x. And if you notice, that's the same thing. So, woo! I did it right. Yeah, so that's all that stuff in there at the fractions you can avoid if you can kind of remember this little trick, and instead of writing x plus 1/3, you could write 3x plus 1. If not, if that kind of throws you off too much or it's too much to wrap your head around, you know, do the best you can with the 1/3 here. Anyway, that's it. That's it for this edition, the second part of our factoring review. I hope you enjoyed it, and I look forward to seeing you again next time. Talk to you later. Bye.